Welcome to the next lecture of regression module, and we'll be talking about the last algorithm of this particular module, that is random forest. If you have understood decision tree, then it will be very easy for you to grab the knowledge of random forest. So basically random forest is an ensembled model over decision tree algorithm. Okay, so what ensemble means? Ensemble means either we combine multiple models or we combine one model multiple times. So that means if you are predicting using any machine learning models and you are using a model, suppose we have used linear regression, support vector, decision tree, polynomial, right? But we have used all these models individually. But if I combine the results of linear regression or support vector regression together and give a result, then it will be an ensemble of these two models, right? So that's why I am saying ensemble means either we combine multiple models, different models, or we combine a single model multiple times. So what random forest is? It is an ensemble of decision trees. That means it combines decision trees multiple time. Okay, so n decision trees are combined together. So we have decision tree 1, decision tree 2, decision tree 3, right? And we are giving all these decision trees the training data we have, and we'll give all the testing input to these models and they will predict their values, right? So we'll be having n predictions for a single testing input, and that n predictions will then be average out. So the final results of this ensemble will be the average result or the average prediction of all these models combined together. So the final model will predict a value which will be the average of all these n predictions, and then we'll be comparing this average with the actual testing input, and then we'll say that this model is this much accurate or this model has this much accurate error, right? So this is how random forest works. The working of random forest is exactly the decision tree, but here what is happening is here we have so many decision trees working together. So this will give a better approach to understand the model and a better prediction. That random forest is basically an ensemble over decision tree, right? So that means it combines different decision tree to predict a result. And in this particular lecture, we'll be doing a hands-on problem using this random forest regression model. So I have already imported the library, and I am importing random forest regressor from ensemble module in the scikit-learn library. Okay, so these are the libraries we have with us. Okay, and the dataset we are choosing will remain the same as we did in the decision tree, and you can clearly see that how random forest works better than the decision tree. So loading our data, the data we have is the Boston dataset. Printing my data, so that's the data I have already shown you. Okay, and it's about the data. Now creating the data frames, right? Then the exploration and checking the null values. There are no null values in our data. Now we'll split our data to input and output parts. Okay, so we are basically predicting the housing values in Boston. So this is the input and this is the output. That is what we are predicting is we are using all the input parameters and we are predicting the minimum value of owner occupied homes. Okay, so we have splitted our values, and now what we'll use is we'll use standard scaler to scale our data. So that's our training input and output. So right now we are using a ratio of 30%, 70:30. Okay, so now we'll initialize our model. So for that, let's name it as, it's a random forest. Okay, so random forest regression. Okay, so let's name our models as RF, and then we'll initialize the random forest regressor. So random forest regressor. Okay, then there are some parameters in this random forest regressor, like the criteria to calculate the proximity in between the data points. So it's by default MSE, that is mean squared error. Then the maximum depth in which we have to search the parameters, maximum features, leaf nodes and all that. So right now what we are basically doing is we are using the number of ensembles. So I'll say 100. That means we are combining 100 decision trees to find out the results, right? So this random forest is being composed of 100 decision trees and they are working at a time over the problem. So initializing the random forest, then we'll fit our random forest, or we can say we'll train a random forest over the training data we have. So x train, y train, right? So model has been trained. Now y predicted values. So y predicted, okay, let's do it over here. So prediction, so y predicted equals to rf dot predict. So what we want to predict is we want to predict x test values. Okay, so that's the y predict results. So y predict, right? And now we'll check the results. So we'll say mean squared error, as we have done in the previous lectures also. Mean squared error. Now we have to compare the y predict and the y test values. Okay, it's a spelling mistake. Y predict, yeah. So yeah, you can see that how efficient this model is working. We are getting error rate of 13% only. That means how well this model is performing, because it is an ensemble of decision trees, right? So you can compare all these regression models on a similar data and you can see how well they are performing and on which data they are doing well. So this was all for this lecture. You are done with the regression module, and in the next coming lectures we'll be talking about classification. Okay, so best of luck and keep following.